Hi, welcome to another video, PiPad Mathematics. I'm Professor Lamb, and this video is going to kind of talk about consecutive numbers, or finding the sum of n consecutive numbers. Popular problem, and this problem has history in Gauss. The story goes that here we are. Gauss is a prodigy child sitting in the classroom. Teacher says, I'm going to give you something that's going to take you a long time to work, so I can sit back and grade papers. I'm adding my own little spice to it. And so the teacher says, okay, I need you to add up all of the numbers from 1 to 100. And so the teacher's thinking, hey, this is going to take forever. I mean, students go 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. It's going to take them a long time. Well, Gauss, probably, let's say a minute later, comes up to the teacher's desk and says, I have the answer, and teacher's baffled. So the question is, what did Gauss do? Or what do we want students to do? So I'm using ExplainEverything to just video record this. The idea is we're trying to say 1 plus 2 plus 3 plus 4 plus ... 99 plus 100. The question is, what is the sum? What is the sum of, not n. In this case, it would be, sum of the first 100 counting numbers. So you're a teacher of mathematics, and you're going to challenge your students to find this solution. Some can sit there and go through the process of 1 plus 2 plus 3 plus 4 and so on, all the way till they get to 100. My philosophy is just get to Dallas. The story behind that is you can take the scenic route, the long way, wherever you live, you can get to Dallas. And I just want students to get to Dallas. Some ways are faster than others. You can get on a plane and fly there. You can ride a bus. You can ride a train. You can take the scenic route through the hill country, wherever. Just get to Dallas. So we want, as teachers of mathematics, to give students an opportunity to solve this problem, to come up with a solution. And kind of what Gauss did, or the way it all goes, is you have students would notice, or you want to get students to notice, that if you were to take kind of the first and the last number in that sequence, it would be 101. And then if you want to take them to get the next number, the first or the second number, and then the second to last number, and add them up, 2 plus 99, you'd get 101. And then you take the third number and then the third to the last number, and 3 plus 98 is going to be 101. So you have 101, and you're going to, because you're pairing these up, first and last, second and second to last, third and third to last, because you're pairing those up, how many pairs are you going to have? Well, you're going to have 50 pairs. So times 50, and that's going to be 5,050 is the sum of the first 100 consecutive numbers. Does that work for everything? Does it work for all of the problems? Well, what you're in essence going to be doing is you're going to be resulting, or you're going to get students to get to a point where they see, all right, well, where did the 50 come from? Because I'm making pairs. So where did the 50 come from? Well, it's that 50 what came from, I had 100 consecutive numbers, and then I divided it by 2 because I'm making pairs, and that gives me my 50. Okay? Well, what was 101? So 50 question mark. What was the 101? Well, the 101 was, well, it was the last number plus the first number, and the last number was how many numbers that were in consecutive, so that's 100, and so that's 100 plus 1, or so that's 101. So if I took 100 divided by 2, and then I multiply that by 100 plus 1, and that's all together. After I get the answer, I have my solution. And you want to get students to see, well, that's going to be n divided by 2 times n plus 1, and then that results in n times n plus 1 divided by 2. That's one way to get it. The idea is when you're teaching this problem, when you're teaching this activity, students are going to come up with all kinds of ways to get this solution. Students are going to come up with every manner of coming up or finding the solution to get to 5,050. One of the ways that students oftentimes get to it is they'll say, well, if I take the 1 plus the 99, then I get 100. And if I take 2 plus 98, I get 100. And I get 3 plus 97, I'm going to get 100. And then you're going to do that all the way down to where you get, I think it's 49 plus 51 is going to give you 100. And then the numbers they didn't add up were going to be the last and then the middle. So the 50 and the 100. So you take all of these, well, how many are there going to be? Well, there's 49 of those, so there's 49 100s plus the 150, okay? Well, you can take all of this and it will eventually, you can mathematically get it down to that formula. Any manner in which the students come up with a solution, that they come up with a way to get to their 5,050, you can show how that way can algebraically work down to be the solution n times n plus 1 divided by 2. There's other problems you can work that help iterate this. One problem is you kind of take it as a staircase. I'm drawing this kind of roughly. But you have 1 and then 3 blocks and then 6 blocks, and the next one's going to have 10. But what you're noticing is you have your 1 and then you have the 2 in the base and then 3 in the base, and how many you're adding up. That eventually comes down to the n times n plus 1 over 2. This n times n plus 1 over 2 shows up in a number of problems, but it's that sum of consecutive numbers, sum of n consecutive numbers. And one of the easiest ways to illustrate that rule, because you're dealing with young children, we're not going into the rigor of finding proof by induction or anything like that. What we're in essence doing is we're finding a way that we have a rule, we can have an example, and then we can illustrate how that rule connects to the example. Give students an opportunity to discover that rule, to make it make sense to them, and actually acting it out or drawing a picture or finding and seeing different ways to get to Dallas. That's what's important. That gets students thinking, that gets them engaged and active and wanting to be problem solvers, because that's going to make them successful in life. And I'm a full believer in that, and that's why I advocate teaching of mathematics. That's why I advocate learning of mathematics and challenging students with these problems. And I don't care how you get to Dallas. I just want you to get to Dallas. And if you add them up one at a time, great. You found a solution. And then later on you want to find something that maybe is more efficient. And then that's for later. But right now we got a solution. So that's just a quick little video here about some of the first n consecutive numbers and counting numbers, and it comes down to that wonderful rule of n times n plus 1 divided by 2. Thanks for watching. Again, I'm Professor Lamb. This is PiPad Mathematics. Take care.